Hello, everyone. Good morning, good afternoon, good evening. Dear authors and invited guests, welcome to the technical session 7C. Myself, Anshika Jain, and this session will be moderated by me. I, on the behalf of Global Knowledge Research Foundation and GS Scholastic LLP, it is my great pleasure to welcome you to the Third World Conference on Information Systems for Business Management, ISBM 2024, Bangkok, Thailand. The third edition of the conference is being organized in a hybrid mode. The physical event is organized today in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow, that is 12th and 13th September 2024. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations, and each presenter will be given 12 minutes for the presentation and 3 minutes for the questions and answers. On 10 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected to us till the closing remarks. In case you have any query or any update, then you can write it to me in the chat box below. Just before we start the session, I would like to introduce you all to the chair of this session, Dr. Surirat Inmore,
Yes.
Associate Professor, Rajamangla University of Technology, Thailand. Ma'am is an associate professor in the Department of Business Administration and Information Management at the university. Her research interests include human-computer interaction, computer, security management, knowledge management, and agronomic system. Welcome to the session, ma'am. Would you like to share a quick opening remarks with us?
Thank you. So welcome on the participant and the moderator. So hopefully we can have a benefit for all of us from this presentation. And okay, welcome you again. You can start it now.
Yeah. And we also have our next session chair, Dr. Uma Maheshwari, Associate Professor, Jaipur Engineering College and Research Center, India. Ma'am is an Assistant Professor in the Department of Computer Science and Engineering at GERCC, Jaipur, Rajasthan, with 14 years of teaching experience and 2 years of technical expertise. Her skill set expands C++, Java, J2E.NET RP technologies with numerous certifications, including in machine learning and network security. She has published around 20 research papers, authored a book on operating system, and has 2 patents to her name. Additionally, she has played key roles in organizing several international and national conferences. Welcome to the session, ma'am. Would you like to share a quick opening remarks with us? Okay, I guess there might be network issue. So we'll be beginning with the session. First up, we have Vishwas to present his paper titled Analyzing Twitter Sentiments, Comparative Evaluation of Classification Models Using Cloud. Are you there? Are you there?
Yeah. Am I audible?
Yes, you are audible. You may begin with your presentation.
Hello to all. My name is Vishwas Prabhu. I am from Manipal Institute of Technology, Manipal, Udupi, which is Karnataka in India. Today I'm going to present my topic on analyzing Twitter sentiments, comparative evaluation of classification models using cloud. So first we dive into an abstract. This study is focusing on mainly the Twitter sentiments, which will be driven in the Twitters. Like nowadays, Twitters are the most highly active social media where the people are tweeting for some text or something images like that. So we need to classify the tweets based on positive classification and negative classification. It's a normal machine learning classification methods. But what we have implemented is we use Azure Cloud for this implementation. So next, sentiment analysis is applied for extract emotion from the textual data. Is normal what the sentiment analysis meant to. We use Azure Cognitive and Machine Learning tools for utilizing this purpose. The research involves sourcing the tweets from Twitter and pre-processing the text. Uh, Yeah, these are the main abstract of this uh, topic. Next, introduction. Twitter provides a rich source for analyzing public sentiments through real-time tweets. The study focuses on classifying tweets into positive or negative sentiments using machine learning algorithms. We are mainly focusing on comparative study. So we use three models. That is, first one is Bernoulli-based, second one is logistic regression, and third one is support vector classification. So it mainly consists of data pre-processing because tweets are in terms of languages or the text. So it's basically we need to do data pre-processing for this because the text are not only the plain text, it may be consist of emojis or some extra things such as special characters also. So we need to extract for our machine learning model because machines cannot understand some thing are not highly efficient that they can understand everything. So we need to do data processing in the cleaning, normalization, and feature extraction are the main things. Next, model are evaluated using accuracy, precision call, recall, and F1 score in the Azure machine learning environment. So we are using Azure machine environment where we can directly use notebook for the model development. Yeah, we are we are use mainly 10 research papers where we can use some research gap where they mainly the Twitter sentiment analysis is used for any one model. So there is no comparative study done which we are finding for that. So we have implemented comparative study as a research gap. So we are using three models over there. Yeah, these are the research gap challenges. Main challenges is no noisy and short and informal tweet remaining unexplored. Underexplored means noisy data, as I discussed earlier. Noisy data means the data which consists of some emojis or some misspelled data or something like that. And yeah, insufficient focus on scalable, robust model that can handle diverse datasets and complex sentiment trends. Objective: develop and evaluate robust sentiment analysis models for Twitter data, improve accuracy in classifying tweets into positive, negative, and neutral categories. But we are actually focusing on positive and negative classification. We are not going for a neutral category, which is a future work for this study. Addresses challenges like noisy polysemy and language ambiguity in sentiment analysis, leverage advanced machine learning techniques and interdisciplinary approaches. Yeah, our proposed method. So for this study, we are using Sentiment 140 dataset, which consists of 1.6 millions of tweets, which is collected from the Twitter. So this dataset we are taken from Kaggle for our model development purpose. So in that they use Twitter APIs. So they are provided APIs also for fetching current tweets which are going on in the Twitter. So these tweets have been annotated with the sentiment labels 0 for the negative class sentiments and 4 for the positive sentiment. But the main study is we need to convert this 0 and 4 into binary as a 0 and 1 because we can't train the model with as 4. We can train, but it's not a proper way. If two classification is there, then we need to use 0 and 1 as a binary classification. So yeah, the dataset mainly includes the following fields such as target, IDs, date, flag, user, and text. The process flow which we are following is first data pre-process preparation has been taken where we can collect our data from Kaggle with the 1.6 million tweets. Then we are build our model. This building model is taken over the cloud environment, that is Azure cloud environment, where we are used machine learning models and we are developed our model and we are taken that model for the uh, testing purpose. Then train and test that modeling, model registration and management, model deployment. Yeah, this is the environment which I uh, explaining. This is the Azure environment where this is the Azure Machine Learning Studio where we are developed our model. This interface will be there in the Azure cloud platform. Algorithms which we are used: Bernoulli's naive Bayes, logistic regression, and support vector classification. The main Bernoulli's is used for the binary classification because it will focusing on true or false. It will not focusing on intermediate things. So if classification true, then it will say true. If it is false, if it will say false. If the classification intermediate classification is there, then this algorithm will fail. So mainly we are focusing on Twitter and analysis. So positive and negative, only two classification is there. So we are using Bernoulli's naive Bayes as well as logistic regression. So this is also focusing on binary classification. So basically it will draws a logistic regression line so that positive and negative classes are divided. Support vector is also working same. Result and discussion. Yeah, this is the confusion matrix, which we are drawn from the Bernoulli's naive Bayes theorem. This is for logistic regression. And our overall table, like accuracy of the model, will be displayed over this table. Accuracy will be highest for logistic regression as 82.84%, and precision recall F1 score as it shown. Yeah, conclusion. Model performance obvious among Bernoulli's naive Bayes, logistic regression, and support vector classifiers. Logistic regression was identified as the most effective for sentiment classification for Twitter tweets. Data preparation, effective data pre-processing, and feature engineering are crucial for optimizing sentiment analysis performance. Application value. Accurate sentiment analysis on platforms like Twitter is valuable for understanding brand perception and public opinion. Future work is algorithm advancement. Future improvement in machine learning and natural language processing technique could enhance sentiment analysis accuracy and efficiency. Integration on real-time data processing, incorporate real-time data stream and contextual information may provide richer insights and support more informed decision making. Dataset and noise consideration. Obviously, this is main thing when we are working with the natural language processing or the uh, text extraction. It's called OCR extraction, tesseract working. So there, the main motto is to work with the noisy data. Yeah, these are the references which we are used for our paper. Thank you.
Thank you so much for your presentation. Ma'am, do you have any questions?
Ma'am, actually, I want the slide to be result and conclusion. I want to see the slide again, ma'am.
Okay.
Next slide, sir. Next, where you are showing the comparison. So your topic says it is based on Twitter data, right?
Yes, ma'am.
In Twitter data, this performance metrics based on which content you are concluding the precision and recall.
Pardon me, ma'am.
No, from Twitter data, you have just mentioned the algorithm names and you are mentioning the accuracy, right? Actually,
Yes.
which data set you have actually taken, that you have not mentioned over here.
Data set I have given over here, ma'am. Yeah, sentiment 140 data set. This one, ma'am.
Okay.
It's taken from Kaggle.
Actually, that this result should be somewhat more specific. I was expecting only that.
Oh, okay. Okay.
It just look like random results, right? So if it is somewhat
Like
more
like
specific,
we have trained our like how we got this result is we trained Bernoulli's neighbors and we taken accuracy of that precision call recall F1 score of that and we are given here and next logistic regression and then support vector for the same data set.
mm, actually in the accuracy level also there is not much variation. Almost
Yeah.
all the three
y-
are providing the same result.
yes
So if
not
you have
much.
taken more specific data set, then you would have gotten at least some a little bit more variation. That's what I want to say.
Yes, ma'am. If we are using other machine learning models, then we are definitely getting the difference between the accuracy. But we are using most common and most usable because we are using binary classification, right? So and language processing. So we are use these three. Yeah, as you mentioned, obviously, if we are using more models, is definitely we are getting a gap between the accuracy.
Okay, sir. That's all from my side. No.
Yeah. Thank you.
Ma'am, do you have any questions?
Yes. May I ask that you use only the English language from the comment or some of the other language with the translation?
You are speaking about the language which we are used,
Yes,
right?
on the comment.
Yeah. Y- yeah, ma'am. We are used English language only for this purpose. Yeah, obviously we can use other languages also, but in that case we need to understand, right, what that language is.
Mm-hmm.
So most of the time, tweeting is done in English, I believe, but I'm not sure. Yeah, so we are, and this is most commonly available and data set for the Twitter and sentiment analysis. So we have taken this one.
Okay. So I
Our
was
main our main intention is to train these models in the Azure cloud. We can train this in our local machine also. We can use which one Jupyter notebook in local, or else we can use Google notebook is also there for training purpose. But our main intention is to this training has to be done and model preparation has to be done in Azure platform only because we are working with the Azure cloud for our current study like current semester. So we are focusing on how we can implement this into the cloud, Azure cloud platform. So that is our main intention.
Mm-hmm. And I think for my suggestion, you could write more on the contribution to how they use it, like the brand tracking or how to promote in business, how to use this one. So just add more section on the practical contribution. Okay, that's a good job anyway. Thank you.
Thank you, ma'am.
Thank you so much for your presentation. Now, moving on
Yeah,
to
ma'am, I have a doubt. Should I be research here for the entire session or I can leave?
so it would be great if you could stay with us till the end of the session.
No, I will be here, but in case if I getting some issue, I can leave, right?
Yeah, no problem.
Yeah. Thank you, ma'am.
So moving on to the next presentation, we have Mansi Solanki to present her paper titled Integrated Approaches to Impurity Detection and Classification in Solid Fluids Using Machine Learning and Spectrometry. Are you there, ma'am?
Yes, I'm here.
You may present your paper now.
Yes, sure. Is it visible and I am audible?
Yes, ma'am.
Okay. So good evening, one and all present here. Thank you for this opportunity. So my paper title is Utilizing Machine Learning Techniques and Spectrometry for Solid Food Impurity Detection. So these are my authors, that is Mr. Akshat Patel, Hetul Patel, Kusha, Mansi Solanki, I myself, Dr. Heidi Jaiswal, Atanu Banerjee, Ms. Deepika Damodar, Dr. Jitendra P. Chaudhary, Ms. Pooja Singh Chaudhary, and we are from Charusat University of Science and Technology, Anand, Gujarat. So let us move on to the next slide. These are the basic outlines of my presentation. So let us go through abstract. So it's what our motto is, what is the motto of our presentation, or what is the motto of our research? To ensure the, as we know that food safety and quality, it is now likely more, there are impurities in solid food, and to ensure the food safety and quality, the detection of impurities in solid food is important. So this research investigate the application of machine learning techniques plus the spectrometry data analysis. Collecting the data through spectrometry is necessary. So we are going through the spectral data was specially collected for experiment through a examination of various solid food samples using NIR spectrometry. And we have used different machine learning models such as random forest classification, naive Bayes, support vector, ensemble learning algorithms, and neural networks. So our results are like, we have got best results from neural networks and got the accuracy of 97.85%. So introduction. So as we know that the safe and nutritious food is basic need for everyone. Ensuring food safety and quality is important to prevent foodborne illness, chronic disease, and malnutrition. So contaminated and adulterated food can cause serious health disease. According to WHO, 600 million people and every 10 people in world every 1 people in 10 fall sick after eating contaminated food, and 4,20,000 die every year, resulting in loss of 33 million healthy life years. So there is vital need for food safety regulation is highlighted by the widespread practice of adulteration, combining chief and inferior ingredients like adding grain mixed with dust and stones, coffee powder with kikari, and turmeric seed powder, sugar or salt with chalk powder, or washing soda or urea. So this research proposes to explore the integration of machine learning techniques with spectrometry to address the challenge of traditional methods, which are time consuming, inefficient, and infeasible for real time analysis. So, we detect and classify the impurity of solid food more accurately by leveraging the concept of spectrometry and the strength of machine learning models such as random forest, naive Bayes, SVM, and neural network. So now let us go through what is spectrometry. Spectrometry is a field of study that measures and interprets electromagnetic spectra. In narrower context, spectroscopy is precise study of colors as generalized from visible light to all bands of electromagnetic spectrum. So what is our goal? Our goal is to measure the absorption of the solid food using spectrometer. So how it works, that it produces the electromagnetic radiations of our samples that can be fluorescence, phosphorus, and electroluminescence. So we have used here phosphorus. So spectrometers are connected with electromagnetic radiations that falls within the optical region of electromagnetic spectrum, which is light spanning the ultraviolet, visible, and infrared wavelength region of the spectrum. So there are mainly 5 types of spectroscopy, that is infrared spectroscopy, ultravisible spectroscopy, neural magnetic resonance spectroscopy, Raman spectroscopy, and X-ray spectroscopy. So in our model, we have used infrared spectroscopy. So this is spectra analysis of our data set. You can see here. We have generated our data set by our own, collecting the food samples from the from our kitchens and all. So I will give brief introduction on my data set too. These are the related works for references. Methodology. So our methodology is divided into mainly 3 phases, that is about data collection, spectroscopy measurement, and implementing machine learning algorithms. So if what about data collection? In data collection, we have used sample of cumin powder, chili powder, salt, sugar, and combination of cumin and salt mixed powder. So generally, we have collected our data set using the spectrometry devices, which I will let you know in further slides what it is. Then the next is about spectroscopy measurement. That for taking the measurement of solid food, we have used two devices, that is UV 3 3600 spectrometer and TIDAS E UVVI spectrometer. Then we have implemented machine learning algorithms after collecting dataset from the spectroscopy devices. So as I mentioned in further slide that we have used random forest ensemble learning SVM neural network in our methodology. So these are the some of the pictures and our data collection methods. So generally we have collected our data set from our university laboratory. So that is about using UV 3600 spectrometer and TIDAS. So basic contaminant is taken and we used to do the uh, like baseline as a calcium phosphate is taken, and then we have implemented our added our data samples, that is of cumin, salt, sugar, chili powder and all, and then we have put it into our machine. That is how we have collected our data set. So if we gone through UV 3600, so basically we have taken calcium phosphate as a baseline. So calcium phosphate takes very, like, it absorbs very less because it is of white color too, and it absorbs very less in this UV 3600. So the picture on the right side you can see is of UV 3600. Then we have decoded the spectrum. So that is about collecting the information from the that chemical data set. So that is about decoding the spectrum. Then the next is chemometrics. Now food samples are often more complex mixtures. So we distinguish information from different spectrum and often requires chemometric techniques. That is, I told already, that is meaningful information is taken out from the chemical data set. And the next step is about the purity measurement. That is quantifying and identifying the use of NIS spectrometer and with the respect to its baseline. And its baseline is calcium phosphate. Now we go through our next machine, that is pixel sensor. So there is 9x9 photodiodes, 8 diodes are there, which ranges from 300 nanometer to 900 nanometer. So our range is visible and near infrared light spectrum, which is generally between 300 to 900. So the range of visible is 700 to 100. So what we have done, that near infrared rays we have taken. Then next is machine learning algorithm. So for our basic general task, we have take hyperparameters, like hyperparameters values same for all of the algorithm. Epoch is 15, loss function is categorical cross-entropy, optimizer is Adam, data split we have done, that's ratio is 80-20, batch size we have taken as 32, and learning rate as 0.0001. So here is the methodologies diagram you can see. So these are the hyperparameters of our artificial neural network. But for every algorithm, we have taken 15 epochs to run. This is our proposed work, that for the input, we have taken spectrometric values, 16 neurons and hidden layer. And in output layers, we have taken our neurons as 5 neurons because there are 5 classes in our methodology. ReLU is taken as our hidden layer activation function, and softmax is taken as our output layer activation function. This is our experimental setup, that is Harvard utilized for it. Generally, we have tried to run our code or the algorithms in Google Colab and in Jupyter Notebook. Libraries we have used is TensorFlow, Keras, Scikit-learn. Matplotlib, NumPy, Pandas, and Seaborn for graphical representation. We have done the task of multi-class classification because there are 5 classes. Then concepts apply is near infrared spectrometry and machine learning algorithm, that is for data collection and to train the data. And the data set is collected by our own, that is using the 2 machines. These are the result analysis. So the left side picture you can see, that is diode 1, diode 2, diode 3. That is the results or the data set visualization of our data set of TDAs, which I already mentioned that 9x9 diodes are there in that machines which absorbs the data, and then the result shows on it, and based on the nanometer range it collected. So basically these are the nanometers like 138 nanometer, 170 nanometer. It is range of the substance of, like if you take cumin, so it is of green color. So this is the green color shows, like the data of green colors or the spectrum value of green color is shown here. So suppose if there is any edible substance, that is white chalk powder is added into the jeera powder or cumin powder, so what happens, the range changes. So based on this we can check the impurity level into it. So these are the result analysis that neural network shows the highest accuracy, that is of 97.85. Here are the F1 score, precision and recall of our model. These are the accuracy versus epoch graphs of neural network and loss versus epoch graphs of neural network. This is our confusion matrix. So what about conclusion and future scope? So our conclusion is that we have used NIR spectrometer for detecting and classifying contaminants in solid food samples, and using machine learning models, we have trained such that it determine the samples that whether it is pure or impure. So if we will focus on our future work, so expanding the data set. Now there are 5 classes. We are expanding into more solid food samples. Moreover, we can focus by developing scalable real-time detection system. Also, it explores to explainable AI or models decision-making process or more transparent to it. These are the references. So thank you, ma'am, and thank you.
Thank you so much for your presentation. Ma'am, do you have any questions?
Okay, let me get started first. So, according to your paper, it's just the ingredient of the food, not the food themselves, right? Just the ingredient.
Yes, ma'am. Solid food samples means you can take any of the solid food sample, that is about ingredient like species or
Before they cook, right? Or after they already cook for the
no,
food.
no. It isn't cooked. It's raw. Species you can we in simple language we can say spices like jeera, cumin, like cumin, sugar, salt. You can even take cheese.
Okay.
So raw materials or raw
It's
spices.
just the raw material, the ingredient, right?
Yes,
So
exactly.
when you test for the contaminant or impurity, is that all the same ingredient have the same measurement of the contaminant? Because I think you did not mention. So you use the same standard, the same measurement for all the ingredient?
Actually, ma'am, if we take about salt, so salt are of 2 types, that is edible salt and the salt used in chemical industries or it is used in laboratories or something. So if we talk about contaminated salt, so let us take an example that in some of the salt, a chalk powder is mixed into it. And in some, while taking the other data set, we are taking salt which is pure salt, like edible pure salt, nothing is contaminated into it. So there will be 2 different spectrum values generated from it.
Okay,
So
so Yes.
Based on that, we have trained our model that this is the pure and this is the impure. But for now, we are just checking our purity, not about impurity.
Uh-huh. Okay, so you might have to write more on the contribution who could benefit from this and like to the business or to the government policies. Okay, so that's for my suggestion.
Thank you, ma'am.
Hello,
Yes,
am I
ma'am.
audible? According to me, also the same query. Actually, you are in your paper, you are talking about the food product, right? Solid
Yes.
food product are saying, but your results are mainly based on ingredients. That too, you just concentrating on salt and pepper.
Pardon me, ma'am. I can't listen the last sentence you
You know,
spoke.
you were just mentioning about the food products in your paper, right?
Yes.
But ingredients also you are not mentioning about all the ingredients of the food material you have taken. Specifically, you will be mentioning about particular food ingredients in your
Yes.
paper.
Yes.
So for that, which are the things you have taken as reference to come to this conclusion? Which are the algorithms you compared with this ANN?
So basically, we have compared the algorithm that is, I already mentioned that random forest, naive Bayes,
No,
KNN.
the algorithm names I can get it, ma'am. But in that, what are the food products are there? What are the contents you have compared?
Okay, that I
The
already,
ingredients you have compared.
yes,
Can I am Dr. Hardik. I am a supervisor and guide of Mansi. Sir, can I explain the question that you asking? Maybe Mansi
Yes, sir.
is in the wrong way. Sir is asking,
Uh-huh.
then you are asking that which is the standard product that you have already taken as in a form of
Yes, sir.
and then we are comparing. Actually, we have taken the standardized result from the our science institute, and we decided some threshold point, and then we are comparing our threshold point with the mix up or the you can consider as the not pure solid foods.
Okay. Because from the result analysis slide, we cannot exactly get how things are compared, right? Just it's showing the algorithm names and the values. So only I wanted to ask this. Okay.
Okay.
Thank you so much for your presentation. So we'll be moving on to the next presentation. Next up, we have Karma Shah to present a paper titled Middle Classification Using Visible Near Infrared ML and Spectroscopy. Are you there? Karma, are you there?
Yes, I'm there.
Okay, you may please begin with your presentation.
So am I audible to all?
Yes, you are.
Good evening, everyone. This is Karma, and I'll be presenting on metal classification using visible near infrared ML and spectroscopy. Moving towards the abstract of our paper, as we know, VNIR are proven highly effective for advanced material and analysis and object identification. Our study hereby is mainly on 4 different metals, that is aluminum, copper, stainless steel, mild steel, and a non-metal, that is wood. Here, for achieving high accuracy, we have integrated machine learning models, that is KNN and random forest, and 2-3 others also. Moving towards the other PPT, I would like to discuss about the research objective of our research. So first of all, metal classification impacts industries like aerospace and automotive, etc. And it is mainly used for quality control. And The traditional methods which were used in India and in many other countries are destructive methods which can be replaced with this method, and our method is a non-destructive method. So going towards the introduction of the presentation. First of all, basically, what is spectroscopy? Here we worked with here we have mainly worked with the reflection, but spectroscopy is typically analyzing the absorption, emission, and reflection, all of that. Coming to VNIR, it captures the spectral data across the wavelengths better than the conventional methods. The methodology, using pixel sensor, we captured spectral data which we analyzed by ML methods to distinguish metals by their unique characteristics. Research was carried in both the ways, that was qualitative method and quantitative method. Going towards the literature review, we were able to achieve the almost 100% accuracy using the methods and the models we used. I would like to show the graphs and the contents. This is the implementation graph. In the pixel sensor, we have 8 diodes, and this is the graph of each and every diode, showing the different intensity or density for each and every metal, how every metal reacts on a particular diode. This is the box plot for various metals for each and every diode from 1 to 8. How each metal gives it intensity on each and every diode. This is the scatter plot for diode 4 and 8. It is the comparison of diode 4 and 8 where we can see some outliers. That is why we have used the ML models in models here, so that we can achieve the accuracy. Here is our accuracy results. We can see that random forest gives us the best accuracy. That is 99.97%. Going towards training and validation loss and accuracy. On the left hand side it is the loss table, and on the right hand side it is the accuracy. So as the epochs is increasing, the accuracy is also increasing. In conclusion, the combination of visible near-infrared spectroscopy with machine learning provides a highly effective method for accurate material classification, achieving an F1 score near 0.99, that is 99%. This approach demonstrates significant potential for improving industrial and quality control, and opens up opportunity for broader applications and including agriculture and plant disease detection. Whatever experiment was done in the room light, that was the embedded light. We would now try for the future work, or for improving our results, we can now try with the more focused lights. So this is the future work. Our project could also be efficient for another applications, such as agricultural related areas, or other than that, the mining perspective and everywhere where we generally do the metal classification. These are the references of different papers we use. And thank you so much.
Thank you so much for your presentation. Ma'am, do you have any questions?
Yes, ma'am. Actually, regarding this sample you have taken along with metals wood also, right?
Yes, ma'am.
But in result, while you were showing only for metal comparison. Then what is the purpose of taking non-metal?
Ma'am, just that because we were mainly concentrating on the reflection purpose, just to show that wood doesn't reflect. That is why we took one non-metal so that we could distinguish between the metals and non-metals, we could easily show that the non-metals do not give the reflection such as the metals gives. That is why for that purpose only we used one non-metal.
But while showing the result, you could have shown the result is coming as smell. So it is not showing any output. So in comparison, you are showing some wood also, but in the result slide, you are not mentioning it. And what are the recent papers you have referred for this month, for this presentation?
Ma'am, I would like my group members also to
Okay.
Tanvi would answer, ma'am. So for this literature review, we have referred 2 to 3 research paper. So in that, first was research paper based on spectroscopy only, where they have taken metal classification and plant classification, which was carried out by Nayak sir. And in that they have classified metals. They have taken metals of copper, aluminium, and basalt fibers, where they have distinguished between the metals. And even for the they have taken in 2 ways. They have taken plant disease classification also. So this was the first one from VNI spectroscopy, and the other one was using surface enhanced Raman spectroscopy, where that it was classifying metal ions into that.
Sir, ma'am, I am a Dr. Hardik. Again, I am from Charuset. These all are my undergraduate students. We actually have a undergraduate project. These all are the undergraduate students. We have the interdisciplinary projects where this project is directly collaborated or related with the industrial application. So our motive is just to classify the metals and non-metals, or even the different characteristics of metals that we need to be identified with the help of spectroscopy. So it is just a portion that we assign to the students. And unfortunate thing, it is only Karma did the good job, but she didn't put it all the references whatever she used in a paper. So number of things.
Okay, sir. No issue.
Thank you so much for your presentation. We'll be moving on to the next presentation. Next, we have Aditi Goel to present a paper titled The Influence of Environmental, Social, and Governance on Mergers and Acquisitions, Due Diligence and Integration. Are you there? Are you there? Are you there, ma'am? Okay. So we'll be moving on to the next presentation. Next, we have Pranali M. Modi to present her paper titled Utilizing Machine Learning Techniques and Spectrometry for Milk Impurity Detection. Are you there, ma'am?
Yes, I am. Audible?
Yes, ma'am. You're not audible.
Am I now audible?
Yeah, you are now audible. You may begin with the presentation now.
Okay. Okay. Good evening. My screen is visible, right?
Yeah, it is visible.
Yeah. Good evening, everyone. Myself, Pranali. I'm fourth year undergraduate student at Charotar University of Science and Technology. It's my pleasure today to present my paper at ISBM online virtual conference. My paper title is Utilizing Machine Learning Techniques and Spectrometry for Milk Impurity Detection. Okay. So these are table of contents. let's just start from introduction only. So starting from milk, as we all know, as is a nutritious and a complete food, rich in macro and both micro and macronutrients, right? Consuming like 2/3 of portion daily gives both adult and children many benefits, having its own high quality fats, proteins, carbohydrates, and vitamins. Now imagine this amount of nutritious and complete food getting adulterated due to highly increased demand in many developing countries. So due to increase in demand and decrease in supply, and also due to increase in gain for profit, due to all of that, there has been increase in uh, adulteration and impurities in milk, such as detergent, skimmed milk powder, or urea, melamine. All of these are like main ingredients which are adulterated with milk, so that they can either sell it and gain more profit, or they can reduce the demand which has been increasing, um, which we found according to national survey in India. So there has been presence of impurities such as melamine, urea, synthetic milk, which increase rise of adulteration practices. Now compromising like presence of impurity, all of these impurities can compromise both public health and consumer trust, as we all know that not only adults but kids also have there for their daily benefits. So let's jump on to like what are the types of milk impurities we can get. First is solid impurity. Uh, talking to all of the coming to all of the solid impurities, main solid impurities which they are like using for making the milk impure or to make it adulterate are I think starch. Then we have ammonium sulfate, which is a water soluble nitrogenous substance, and is offered is used as adulterate to mask the presence of extra water. Then cane sugar, as we all use in our I'm sorry, yeah, in our daily on a daily basis to disguise the presence of extra water and to increase the specific gravity. There are other solid impurities too, which include sodium chloride, which is table salt, which we eat on daily basis. It's not for not used as main ingredient, but to thicken fake milk by increasing its specific gravity again. And melamine, it's highly used adult like impurity, which is used as solid milk impurity. So due to its high nitrogen content, it is added to dairy products like milk and to enhance their protein content. Like this, many other harmful additives like soap, detergent, and food colorants are also being used to modify the milk, right? So these are the images which are being used, and which we have done literature review on. Coming to liquid impurity, whey, which is a byproduct of cheese, which is a good protein content, which is not bad as a if we human body intakes it, but it loosens the milk fats, and milk proteins which are already there in pure milk. So whey could be one liquid impurity. Then there are vegetable oils. These wherein low value milk is mixed with higher value to boost profit again. And next is chlorine. Chlorine is not used as a like for highly impure as a highly impure substance, but to just adjust the density and mastitis in cows to increase you know chlorine levels naturally in body in milk. So this chlorinated milk can be lead to heart disease and many other disease related to it. Also hydrogen peroxide. So these are the images. Now main motivation that as we saw earlier, that milk, as we all know, that is a fundamental component of daily nutrition, and we all have it and plays a crucial role, not only milk but also milk products. So due to increasing demand rise, there has been notable surge in adulteration cases also. Now we earlier, before starting this research, we have gone through some traditional methods for detecting milk adulteration, now which were very slow or either expensive or require some complex laboratory setups for detection. So our main motive or our research objective was to make system available which is easy to classify or easy to get to know about milk, that okay, this is pure milk and this is impure milk, via a system which already integrates with the machine learning and spectrometry. So spectrometry we used for data collection, data set or collection of data set for pure and impure milk, and machine learning we trained our machine learning model so that it could detect whether this particular features with this particular milk, is it pure or is it impure. So based on previous all slides, we have defined the problem statements. So to address all of these limitations, this research explores the integration of machine learning with NIR, that is near infrared spectrometry, which we as a human eye cannot detect. We cannot find out, like there might be cases where we have drunk impure milk, but we couldn't differentiate it. So after visible range, that is a near infrared region, that's when the machines and spectrometry comes into picture, which they can detect that okay, this particular absorption or reflection of light is something different than the previous one. So yes, talking about spectroscopy, it's like study of interaction between matter and electromagnetic radiation. As we all know, there would be a light source, there would be a wavelength selector, and there would be a sample, which then later would be detected. Okay, there would be particular diodes from 1 to 8, and all of them would be reflecting differently. And most probably the last diode, which is diode number 8, would have the more fluctuating readings as it's near to the infrared NIR. These are the principles of spectroscopy, which has been covered earlier. But like when light has been incident, there has been matter which either takes absorption, or there photoluminescence happen, or transmission happen, or scattering happen. So we have worked on what light has been absorbed, and these are certain frequency and wavelength range which electromagnetic spectrum has. So here in near infrared we are working on, and these are the wavelengths for electromagnetic spectrum. Okay, for our data set, we have taken both solid milk samples and liquid milk samples. For solid milk samples, we have taken milk powder and whatever specified half a tablespoon of sugar mixture, flour mixture, coffee powder, cow milk, all of that we have mixed with each other, and we have conducted a research and collected our data. Likewise, it goes for liquid milk samples. These are the images which we conducted.
Sorry to interrupt you, ma'am, but you have 2 minutes to conclude your presentation.
Yes. Okay. And this was the latitude. Okay, this is how we conducted our experiment. This is a specification for multispectral sensor. This was the literature review which we conducted earlier. Earlier, there has been methods which has used this particular thing, spectrometry and machine learning, but it either lacked in accuracy or lacked in detection of common adulterants. This is how we implemented our project, our research. So we have used supervised machine learning, that is labeled machine learning, which we would label it as pure and milk, pure and impure. Here it has the example. pure and impure milk would be labeled. And likewise, we have divided our portion data set into training and testing, and later part would be tested by machine that okay whether the milk is pure or impure. These are the results for K nearest neighbor for MLP, that is multi-layer perceptron. And these were the results what we have achieved for with precision, recall, F1 score, and accuracy. And in conclusion, right now combining both NIR and spectroscopy, there has been increase in certain detection method, and we could see like here as we saw, random forest could give 99.84% accuracy, which is almost near to a truth value which we want. So yes, this was it. And our future scope includes mixing more impurities into milk or milk powder so that we could detect more impurities. And also we can implement this particular system in real life containers, real life milk containers which are used in industries, and so that they could also detect that okay what particular thing is pure or impure. And these are the references. Yes, thank you from my side.
Thank you for your presentation. Ma'am, do you have any questions?
No query from thy side. This is very good presentation because everything was clearly explained. So no query from my side.
Thank you, ma'am.
Okay,
Any
it's
other
no
question?
question from me.
Yeah.
Thank you, ma'am.
Okay. So we'll be moving on to the next presentation then. Next up, we have Jerry to present his paper titled Value Creation with Natural Products in the Food Chain. Are you there, sir?
Yes, I'm here.
You may please start your presentation, sir.
Okay, let's see. So, can you see my presentation?
Yes.
Yes.
Good. So, thank you for this. My name is Juri Vilko. I'm an associate professor at LUK University, and this research about value creation with natural products in the food value chain has been conducted by me and mainly my master student, Lilli Huovila. And first, I would like to talk about the introduction. So the natural products are increasing in popularity in customer demand and have been experienced an excellent way to improve sustainability in the food value chain. Now, natural products have been in many cultures, this kind of ancient way to produce food stuff and so on and so forth. However, in the modern society, they have been somewhat neglected and now are increasing in popularity as people are asking more purity and food security and safety and so on and so forth. However, as we have forgotten many of these traditional ways to consume the natural products, some of the information and some of the know-how of their use have been forgotten also. And also these kind of new processing methodologies are improving the ways we can utilize the products. However, in order to manage the role of natural product in the food value chain, the value dimensions of different supply chain steps need to be identified and assessed, and how the value is created in the networks and in the supply chains, and what kind of value exactly are we producing and providing the customers and final customers in the supply chain. So the goal of the study was to investigate the nature of value with regards to natural products and how the value is created. And we have a case in Southeast Finland, and especially we're focusing on berries and mushrooms in these cases. And it includes literature review and also empirical part where qualitative research approach was utilized, and namely semi-structured interviews were executed to identified actors in the field. First, if we think about the value creation in the network, we are using this Kotha, Daram, and Wilson's example. So how the relationships, how the core capabilities, and how the superior customer value are being created, and what kind of elements are there in this. Furthermore, we are utilizing Porter's value creation model for enterprises. But if we go into more deeply in the natural products in the food sector, basically they can be defined as being natural by origin, unmodified, and without additives. And the most traditional downstream processes of these products are various types of jams or juices or extracts or so on and so forth. And different processing techniques can improve the shelf life and thus make the market value of natural products to increase. And furthermore, there's many initiatives in Finland supporting this kind of use of natural product, as they are wild products and they can be utilized more purely than many of the cultivated ones, as we are using different kind of substances in order to improve their growth. But in here, they are from the forest, they are wild, they are pure, and in thus more safe, secure in many ways. Now, if we think about an example, for example, from the berries, due to the variation of the supply or harvests in these different berries or mushrooms, we can see a high variation. So depending what kind of materials, what kind of natural products we are talking about, the variation can be extremely high, which of course makes it difficult to estimate the supply from year to year basis, and then thus also would speak on behalf of processing them more, improving the shelf life, improving the storage abilities of these different products. If we go to the value formation of these natural products, the value chain comprises from a series of activities that the company or actor performs to produce the product or service and create value for its customers. In this study, the value is divided into 4 different types. So first, utilitarian, secondly, hedonic, thirdly, social, and finally, epistemic value. And in here, utilitarian value emphasizes the functional or product-centered thinking, and it refers to the practical utility of a product or service and its ability to meet the need, meet this some kind of practical, concrete need. Now, the hedonic value refers to the pleasure or enjoyment delivered from a product or service, so it's more emotional in its nature. Now, the social value refers to the value that arises from individual social relationships and interactions, and in many ways has symbolic elements as well. And finally, the epistemic value is based on the ability of products to arouse curiosity and provide new experiences. So as we can see, a lot of these abstract value elements are included, and also if we think about this kind of natural product and purity and so on, they are quite abstract and sentimental in their nature, which makes it, of course, more difficult to measure. However, we need to take these value elements into account, and then the previous studies actually have proven that the emotional type of value elements are more important than the economic ones, and furthermore more important than the functional ones in these kind of situations when customers make their choices. Talking about the research design applied in this research, first we conducted a preliminary literature review, which focused the problem setting and forming research questions and aim. Thereafter, when the research questions and aim was done, we conducted integrated literature review into this subject. And based on that, we formed semi-structured interview guide selected and identified and selected informants and conducted and recorded the interviews. After the interviews were recorded and transcribed, we did qualitative coding as an empirical analysis method, and finally reported the results and conclusions from there. Now, we had 9 different interviews, and in here you can see the informant's role in their own company. So many of them were owners, some were co-owners, some were bigger companies with a project manager or chairman of the board. So we wanted to have this kind of different kind of perspectives, and also some of the companies were only doing part-time business in this natural product sector. Some were full-time as well. So as you can see, the company size, there are different sizes, but all are small companies. So basically, it highlights the typical companies that are in the sector, and in many ways we could identify that the lack of information, lack of knowledge and know-how were actually hindering the going forward in this sector and making more profit with these natural products. The experience of the informants was varying between a few years and over 34 years. So one was less than 1 year. And also their role in the supply chain varied. So they were in different parts of the supply chains. Now, as we coded the data, we identified different kind of value dimensions there from these four perspectives, and furthermore, different kind of process steps for the natural product, which can be seen here. So, for example, the value dimensions for utilitarian or in quality, taste, different kind of properties that the products had, and availability. Hedonic value was the background story, so what kind of narratives was in the background, and a pleasure factor, so how these kind of narratives, how these kind of berries would set into the value elements that the customers had themselves. Also, social and labels and certifications demand and labels and certifications were seen in the social value elements, and in the epistemic value elements, new knowledge, new experiences were seen to be substantial. Furthermore, if we go into the value chain, basically we started with the raw materials collection. There are the raw material sourcing, processing, downstream processing and packaging, and finally sales and marketing. And all of these steps have different kind of actors in there. And basically the whole process was initially seen quite simple and short. However, we also saw that there were new kind of processing potential for these natural products that in the future might complicate this process and furthermore add value. And talking about adding value to this, here's an example with blueberries, for example, how the price per kilogram changes when the process goes forward. So, for example, if we have fresh, uncleaned blueberries, it's typically 1.4 euros per kilo. When you clean the blueberries, it increases to 4 euros per kilo. When you dry and make powder out of the blueberries, then it's 100 euros per kilo. And finally, the extract is 2,000 euros per kilo. So there's many ways to increase the value per kilo and then process the different natural products. So this is just one example from blueberries, and actually we're continuing with this research and going forward in studying many other natural products, as this is part of a larger project being conducted in Finland currently. Finally, the results about different kind of value elements, as already mentioned. So this kind of quality and taste were seen in the utilitarian value. In the hedonic value, this kind of traditions, again, we're talking about this kind of narratives and purity, domestic and location where they are sourced from, and the origin of raw materials as such plays an important role. Background stories of the product, of course, again, how and who has, for example, been picking them, who has been processing them, so on and so forth. So we're talking about the transparency and visibility of the supply chain in here, which increases the value. In epistemic value, this kind of new raw material combinations. So, for example, adding natural products to some other foods, for example, might add the value substantially. And this kind of new innovative recipes, this kind of new stuff that could be a potential hit or seen as a good potential for epistemic value creation. Also, research knowledge on natural product was seen to increase the value. So currently, one of the biggest hindering factor, as already mentioned, was the lack of information and knowledge in this sector. Finally, the social value elements or certificates and labeling. So some kind of standardization or certification which somehow gives certainty and validation for the purity and for different kind of value elements. So locality of the food was an important, the organic food as such, but in here it's not only organic, but it's wild, which makes it, the taste is a little bit different, and also it's more natural in that sense. And finally, the environmental friendliness, which was an important factor in terms of sustainability. Lastly, the conclusions. So basically, with this study, we have illustrated different value dimensions. The research was based on master's thesis work conducted this year. And the study gives insight about different steps in the process. So now we are looking more deeply in acquiring more knowledge, how the value is created and what type of value in different processes, steps is being done. Also, the results of the nature of the value can be used in practice. For example, marketing the natural products, seeing, okay, what kind of elements are substantial marketing elements, marketing information for those natural products. By identifying these processes, it's possible to develop, identify, and analysis, conducting analysis for these supply chains, for this value creation network, what's happening, who's doing it, and how. Now, further research should be conducted and is currently conducted with different products. Also, we are benchmarking different regions and thus getting more information about the phenomenon. With this, I would like to thank you. If there are any questions, I'm happy to answer. Thank you.
Thank you so much for your presentation, sir. Ma'am, do you have any questions?
Yes, may I start first? Okay, so this is a qualitative research. So you interview with the 9 business owner, is that correct?
Not all of them are owners, but there were 6 owners, 1 co-owner, 1 project manager, and 1 was chairman of the board and partnering in the company.
Okay, from this PowerPoint slide, I can see that they kind of small business, right?
Yes, all are small business.
Yes.
And actually, the interesting thing that in many of these very picking thing, we're utilizing Thai workforce.
Mm-hmm. Yes, and may I suggest something? I think when we asked about the business model, to increase the value chain for the food, is might get the correct answer or more precise answer if we could ask the customer the customer who buy this product and ask them for the opinion instead of ask the producer of the product, the owner. If we could send the questionnaire to the customer who buy the product, maybe we get the answer that's more useful for their business. That's for my suggestion.
Yes, that's an excellent point. Currently, basically, we had to focus on some part of the supply chain, and we have different people looking at, for example, the restaurants and their procurement, and also those are looking at the final customers of this. So this research was limited to the downstream supply chain, and now actually upstream supply chain. So the downstream supply chain is being focused by another researcher who's conducting actually a doctoral thesis about this matter. So we're looking more precisely into the customer point of view, and that's an excellent point. Thank you.
Thank you so much, sir. Ma'am, do you have any questions? Okay, I guess no questions from our side. Do we have Aditi Goyal to present her paper?
Yes.
Okay. Ma'am, you may present your paper now.
Sure. Good afternoon, esteemed guests, fellow researchers, and distinguished judges. It is a great honor to be present here in this online mode for ISBM 2024 conference. So it is evident that the business world nowadays is undergoing a profound shift. Increasingly, companies are not just basically valued for their financial metrics, but for their commitment to environmental, social, and governance principles. So today, I, Aditi Goyal, along with Karthikeya Jain, and under the guidance of Professor Amala Sibbi, will present our research paper on the transformative role which ESG plays in mergers and acquisitions, an area of growing importance that bridges financial performance and ethical responsibility. The title of our paper is The Influence of Environmental, Social, and Governance ESG on Mergers and Acquisitions, Due Diligence and Integration. So from our presentation, we aim to showcase not just the role of ESG that it plays in today's corporate strategy, but then in the future, it will hold what it will hold for mergers and acquisitions. So we'll delve into the challenges and the opportunities and also the best practices. And now the coming to the abstract. So basically, so our paper, it actually pays attention to the ESG factors, how they are transforming the traditional due diligence process in the mergers and acquisitions, providing more of a comprehensive approach to risk and opportunity assessment. We also demonstrate that how companies can evaluate environmental, social, and governance impacts of their target acquisitions by incorporating them into strategic decision-making to enhance the financial performance and long-term value creation. So our findings basically emphasize the importance of early ESG integration, efficient due diligence practices, and also the post-transaction monitoring, settling the foundation for basically the future research in the evolving field. Coming to the introduction part, so the role of environmental, social, and governance in mergers and acquisition has gained increasing importance in recent years, basically. So with stakeholders paying major attention to a company's social impact, environmental sustainability, and governance practices, ESG considerations are becoming a crucial part of mergers and acquisitions due diligence. In our research, we explore how early integration of ESG elements not only mitigate risk, but also uncovers the opportunities for value creation, leading to more successful and mergers and acquisitions transactions. Also, now coming to the our research gap. So, despite the rising importance of ESG in mergers and acquisitions, research remains limited on its application in due diligence and integration processes. So our study basically addresses this gap by evaluating the impact of ESG considerations on mergers and acquisition success. We focus on how businesses assess the ESG performance of target companies and maybe the challenges of aligning the ESG practices between merging entities and the best practices for successful integration. Now coming to the methodology part.
So our research basically adopts an extensive literature review approach to evaluate the ESG factors in mergers and acquisition transactions. We examined various case studies and empirical data to understand how ESG considerations affect risk assessment and the integration challenges and long-term value creation. We have also analyzed the impact of governance, social responsibility, and the environmental practices in both the pre and post transaction phases. Also, now coming to the objectives. So basically, our study aims to assess the significance of ESG factors in the mergers and acquisition decision making, and also to evaluate the effectiveness of current ESG due diligence practices, and also analyze how ESG ratings influence company valuations and merger acquisition deals. So our findings are in the environmental factors. So ESG due diligence highlights a company's environmental impact, including resource efficiency, pollution levels, and commitment to sustainable practices such as carbon emission reduction. And in case of social factors, so companies are evaluated based on employee treatment, customer satisfaction, and maybe diversity initiatives and their overall community engagement. And in case of governance factors, so our study basically focuses on corporate governance structures, including the board composition, transparency, executives, compensation, and also risk management policies. Companies that have high ESG ratings now are more attractive for mergers and acquisition deals due to maybe the lower risk profiles or improved long-term value and better regulatory preparedness. And now due diligence of ESG in mergers and acquisitions. So the ESG due diligence process in mergers and acquisition focuses basically on the ESG factors. Practitioners review the target company's ESG reports, policies, financial statements, and the regulatory compliance. They also gather feedback from maybe the stakeholders or ESG rating firms and external experts like environmental consultants to assess the company's sustainability practices and maybe the potential risks for that. And coming to challenges part, so quantifying the financial impact of ESG practices is challenging, as the benefits like lower regulatory cost and brand loyalty are difficult to predict. Inconsistent ESG data and evolving regulations across jurisdictions further complicate this process maybe. And also aligning the ESG values between companies post-merger is complex, and experts often lack the skills to access these ESG risks thoroughly. And then maintaining strong ESG practices throughout the integration remains a very significant obstacle maybe. And now coming to the early integration of ESG in mergers and acquisitions. So in pre-merger, buyer assess the target company's ESG performance to identify the risk and maybe the non-compliance and the areas of synergy. So aligning our ESG standards between both the companies ensures a consistency to prevent a drop in the ESG ratings. And in case of mid-merger, the value creation extends beyond risk management by basically leveraging the ESG practices from both the companies. This can actually result in tangible benefits like reduced costs through sustainable procurement or improved employee retention. And in case of post-merger, so the ongoing evaluation of ESG practices and performance is essential to sustain long-term goals. Like continuous monitoring aligns ESG benefits with the company's strategic objectives, and it can promote the value creation. Now coming to the best practices for the ESG integration in mergers and acquisitions. So in pre-transaction due diligence, companies must conduct the thorough ESG due diligence, focusing on sustainability reports or maybe the governance audits and stakeholder engagement. This can actually help in identify any misalignments maybe between the two entities and uncover the potential synergies or risks. And in case of strategic alignment, so successful mergers and acquisition integration requires the ESG goals of both the companies, basically establishing clear ESG metrics and the governance frameworks, and to ensure that smooth integration is there to promote the long-term sustainability. And for the post-transaction monitoring, so there should be a continuous ESG monitoring post-merger, which is critical to maintain the alignment with sustainability goals. Companies should basically establish the KPIs to track the ESG performance and to make necessary adjustments so that they can stay aligned with the stakeholders' expectations. Now, future scope. So for our research, the future scope could focus basically on the sector-specific impacts of ESG, particularly in the industries like renewable energy, or maybe developing the advanced valuation methods that incorporate long-term ESG benefits. And also they can explore the use of artificial intelligence and other technologies in the ESG due diligence and integration. And the conclusion statement for our research would be, so in case of ESG integration in mergers and acquisitions, this is no longer an optional thing. It is basically a critical driver of the success element. Our research basically highlights how strong ESG frameworks can minimize the risks and enhance value creations in the mergers and acquisition deals by basically incorporating ESG into the entire mergers and acquisition life cycle, from due diligence to post-merger, and monitoring the companies basically. So that is how companies can achieve more seamless transactions and improve their financial performance, and also how can they contribute to the sustainable growth. That's it from our side. Thank you.
Thank you so much for your presentation. Ma'am, do you have any questions?
So may I ask that, is that your proposed model for what kind of specific business that you propose this to?
I'm sorry, can you repeat the question?
Okay, so I might missing some part, but what kind of business or industry that you propose this model to? Do you have specific business to propose this model?
No.
No, it's that you study in general for any business, right?
Yeah. So this is a generic study for a. It actually we took the data from empirical data.
Okay, so it's just like your future work is might be more specific business just to get the full benefit of your model. Okay. Okay, that's for my part.
Okay, ma'am, do you have any questions? So,
No, thank you.
okay. So I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope the session was informative enough for each one of you. We, on the behalf of the whole team, thank you for your support during the third version and all the previous two versions of this conference. We will be happy to have you in the fourth version in 2025 as well. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the printer. The publication will be live within 6 months, so kindly cooperate with the team of ISBM 2024. I would also like to thank our session chairs for chairing this session. Thank you so much, ma'am. This is a token of appreciation on the behalf of the whole team of ISBM 2024 and Global Knowledge Research Foundations. Would you like to share a quick closing remark with us?
So thank you for on the presentation paper. It was valuable and give us more informative. So just some thing to think about and thinking for the future, especially for some of the food safety. So thanks again for on your informative that give us. Thank you.
Thank you for your valuable presence, ma'am. I would also like a moment to thank Dr. Uma Maheshwari, ma'am, for chairing this session. Thank you so much, ma'am. Would you like to share a quick closing remark with us? Okay, there is some network issue from ma'am's side. Okay, thank you so much, everyone, for your valuable presence. I would request everyone to please switch on their cameras for a quick snapshot. Thank you so much, Okay, I'll take one more. Thank you so much, everyone. Thank you.
You're welcome.
Thank you.